Hello, in this video we study derivatives of trigonometric functions. Let's start from two basic functions, sine and cosine. Let's accept that the derivative of sine is cosine and the derivative of cosine is negative sine. You can see the proof in the textbook, and actually proofs are not difficult at all. Okay, so if you have that, then we can apply the quotient rule to find the derivative of tangent. Let's do that. We write tangent as sine x over cosine x. Okay, then from here, tangent derivative is equal to, according to the quotient rule, I have sine derivative times cosine x minus sine x times cosine x derivative divided by cosine x squared, right? That is the quotient rule. Let me remind you that, right? You have f over g derivative is equal to f derivative g minus fg derivative divided by g squared. Okay, then derivative of sine is cosine x times cosine x minus sine x. Derivative of cosine is negative sine. Okay, and I have cosine x squared. So on the top I have cosine squared minus, with the negative, will be plus sine squared. That is cosine square x plus sine square x over cosine x square, or cosine square x, right? Whatever you want. Okay, let me write here. Cosine square x is cosine x, everything square. That is just notations. All right, so we know that sine square plus cosine square is 1, right? Sine square x plus cosine square x is 1. So from here, I get 1 over cosine x square. I write here tangent x derivative is 1 over cosine x square. Okay? If you just want to use this one, right? And you want to break this function into two functions. So what do you have? I can write like, okay, I copy in here. This also equal, right? So I have cosine square x over cosine square x plus sine square x over cosine square x. So basically, what is that? This is equal to 1, right? And this is tangent x, everything square. You see that? So, another form of the derivative of tangent is 1 plus tangent square of x. You see that? So it depends on the situation. Sometimes you may use the derivative of tangent is 1 over cosine square, or the derivative of tangent is 1 plus tangent square. I'll tell you, right? This is extremely useful when we study integration. So please don't forget that. All right? Similarly, you can find the derivative of cotangent by writing cotangent x as cosine over sine x, right? Let's do that. Cotangent derivative is cosine x over sine x derivative. Again, you need to use the chain rule. The quotient rule. So you have cosine x derivative times sine x minus cosine x times sine x derivative divided by sine x squared. And we know cosine derivative is negative sine times sine here. And then derivative of sine is cosine. So I have cosine times cosine divided by sine square x. Sine square x. Okay. On the top, you have sine square and cosine square with negative, you see? So basically, that should be negative 1 on the top. Is that correct? Oh, okay, let me rewrite that, right? That is negative of sine square x plus cosine square x. I just factor negative out, right? And use parentheses. And have sine squared x in here. So you might have negative 1 over sine square x. You see? And similar to the previous case, you may break this function into two functions. So you might have negative sine square x over sine square x plus cosine square x over sine square x. You see? And here you have 1, right? That is the first term. And here you have cotangent x squared. So that is the derivative of cotangent. Again, you may use this formula, right? Or this one. Okay? So look at this. Let's compare, the formula of tangent and cotangent. So this is derivative of tangent plus 1 over cosine square or 1 plus tangent square. And the derivative of cotangent is negative 1 over sine square or negative 1 plus cotangent square. You see, with cosine you have negative sine. Cotangent you have negative 1 over sine square, right? But for tangent you have 1 means plus 1 over cosine square or plus 1 plus tangent square. Okay? So that is about, derivative of 4 basic functions. If you want to differentiate sequence or cosequence function, you also use the quotient rule. Let's see this. So sequence of x, right? What is sequence of x? That is 1 over cosine x. Is that correct? And now you differentiate this function, you use the quotient rule. Secant x squared, the derivative is 1 derivative times cosine x minus 1 times cosine x derivative over cosine square x, right? But 1 derivative is 0, so we don't have the first term. For the second term, I have negative sine of x, because the derivative of cosine is negative sine, right? So you have in here cosine square x. So that is sine x over cosine square x. Of course, you can rewrite this as sine of x times divided by cosine of x, okay, and times 1 over cosine of x. You see that? You just break cosine square, right, into cosine times cosine. So this term is tangent x, and this guy is sequence of x, and that is the derivative of x, a sequence of x. Sometimes you write sine of x over cosine square x. All right. Similarly, you can find derivative of cosequence of x, because we know that cosequence of x is 1 over sine of x. And you use again the quotient rule. Let's do this. Equal to 1 derivative sine x minus 1 times sine x derivative over sine square x. And again, the first term is 0 because 1 derivative is 0. The second term is negative cosine of x over sine square of x. And what is that? You can write as negative cosine x over sine x times 1 over sine x, right? Then that is negative cotangent x times cosecant x. Is that correct? Because this is cosecant and this is cotangent. So that is the derivative of cosequence. All right, so now we have derivatives of all 6 basic trigonometric functions. Again, we need to copy those formulas somewhere, right? So that each time when you practice, you have something to watch. You have something to check, because I repeat again, right? I don't require you to memorize anything, and I think I don't recommend you to do that. But if you practice enough, those formulas will be in your mind. Okay? Let's consider the following functions. Y equal to x plus cosine, y equal to 3x squared sine of x, and y equal to 1 minus cosine over sine. Let's find their derivatives. Okay? So for the first function, I just need to take derivative of x and derivative of cosine. That is 1 minus sine x. Okay, derivative of cosine is negative sine, right? For the second function, I need to use the product rule because we have product of two functions over there. I have 3x squared derivative times sine of x plus 3x squared times sine x derivative. And derivative of 3x squared is 6x, right? We have 6x times sine x plus 3x squared times cosine x. That is the derivative of sine. That's it. Okay. For the last problem, you might use the quotient rule. So let's use the quotient rule. Okay. So I have 1 minus cosine x derivative times sine x minus 1 minus cosine x times sine x derivative over sine x squared. You know, if you pay attention, when I use the quotient rule and the product rule, I don't change the order of f and g. Remember that? You know, if you have f and g, right, and take the product, and you have, derivative is fg, I write fg plus fg, and then I move the symbol in this from f to g. So I have two terms. You see that? But if I have, quotient, and I take the derivative, first I write g squared in here, and again I will write fg in here. The first one I have f derivative g and g derivative f, but for the quotient I have negative. You see, I don't want to change like f derivative g plus g derivative f, because otherwise, I might forget the sign in here. Does that make sense? In my experience, some students did that mistakes because sometimes you interchange the position f and g, and then they do wrong, right, in the sign of the quotient. Sometimes that they mix up with this. Okay, so I very recommend you just keep the order fg, and then you move this along f and along g. Similar case for the quotient rule. So, I write, 1 minus cosine derivative sine minus 1 minus cosine sine derivative. You see that? Then I have 1 derivative is 0. Negative cosine derivative is negative of negative sine, right? Because derivative of cosine is negative sine. I have sine here. And in here I have 1 minus cosine times cosine divided by sine x squared. So I have negative would be plus, right? So I have sine squared minus, I will, for this out, I have cosine, and then minus cosine squared. You see that? So I have sine x squared. Again, of course, if they don't ask you to simplify, you might stop at this step, right? You don't have to simplify that. Agree? But here I do more work. Anyway, this is fine. So I have sine squared minus cosine plus cosine squared. We have negative, right? With the negative, so you have plus in here. And divide by sine x squared. And you might simplify sine squared and cosine squared, because sine squared plus cosine squared is 1. So I have 1 minus cosine x over sine x squared here. You might do this way, but again, right, if you remember the quotient rule, you might stop at this step. Agree? Or you might do in the other way. How? So you might think like, yeah, this function is nothing but 1 over sine x minus cosine x over sine x. What is 1 over sine x? that is cosecant of x minus cotangent of x. And then you differentiate this function and this function, you get what you need. Okay, so I've left that for you. Before we finish this video, I would like to solve one tangent line problem with trig functions, and then I think we can finish. Let's find an equation of the tangent line to the graph of the function y equal to tangent of x at the point pi over 4, 1. Means x equal to pi over 4 and y is 1. Okay, so again we need to find the derivative, right? Y prime equal to tangent x derivative, and we have two formulas, whatever you want to use. So I use just 1 over cosine square of x. All right, and from here I can find the slope of the tangent line at pi over 4. That is 1 over cosine square pi over 4, right? But what is cosine of pi over 4? Cosine pi over 4 is 1 over square root of 2. Then that is 1 over square root of 2 and then square. So you simplify this, you get 2. From here you can write the equation. That is y minus y0, which is 1, equal to 2 times x minus pi over 4, or y equal to 2x minus pi over 2 and plus 1. All right, so you have trig functions, that's fine. You have polynomials, that's okay. You have fractional function, that is also good. Even product of some functions, you still need to apply differentiation rules to find derivatives, right? If you want to find the equation of the tangent line at some point. So that is the key. Agree? So I hope you enjoyed the video. If you have any questions, please feel free to let me know. Bye-bye.